Okay, so there is this problem in assignment 4, question number 4 on Bayesian networks, to which I will provide an alternative solution that was given in the alternative to what I gave uh, in the Saturday session. So the question is that you have been given a Bayesian network, and so the probability that there is a wet grass that could be caused by rain or a sprinkler. And here is the probability of rain, probability of sprinkler, probability of wet grass given rain and sprinkler, probability of wet grass given rain and not sprinkler, probability of wet grass given not rain, sprinkler, probability of wet grass given not rain and not sprinkler. So these are given, and you have to calculate probability of sprinkler given wet grass and rain. So you see, this is the inverse probability that you have to calculate. So what has been given is the probability of wet grass given these rain or not rain and sprinkler and not sprinkler. But you have to calculate the probability of sprinkler given wet grass or rain. So here you need to apply Bayes theorem, and we'll see how we can do it uh, easily or in a shorter way. Okay, so you see, this is what has been given in the question. So these are the probabilities. Uh, this is what is given, probability of rain, and from there I have to calculate the probability of not rain, not sprinkler, probability of wet grass given rain and sprinkler, and from there basically I have calculated the complement probabilities. Now you have to calculate probability of sprinkler given wet grass and rain. So this thing, probability of A given B, if you remember from Bayes theorem, we can write it like this. So Bayes theorem is probability of A given B equals to P of B given A times P of A divided by P of B. So this is exactly what I've written. Probability of S given W and R is probability of W given S and R. So I just transferred W to this side and times probability of S given R divided by probability of W given R. Okay. So now we have to calculate the individual components. So probability of W given S and R is given over here. So this is 0.8. Now I have to calculate probability of S given R. So if you see from the network, sprinkler and rain are independent of each other, right? So the network was something like this. Here you had wet grass, here you had sprinkler, here you had rain. Okay. So basically, rain and sprinkler are not connected by any node, so they are independent of each other. So for independent events, P of S given R would be equal to P of S. Okay. So P of S given R equals to P of S. And what is P of S? It's 0.2. P of W given S and R, it is given here, which is 0.8. And then we are left with P of W given R. So P of W given R can be calculated from the law of total probability, right? So P of W given R would be P of W given S and R plus times probability of S given R plus probability of W given S complement R times probability of S complement given R, right? So basically, you have to see that uh, this when we are applying law of total probability, you have to see the probability of W given R. There could be two cases, whether sprinkler is on or sprinkler is off. So you have to sum over those two cases. So probability of W given sprinkler on times probability of sprinkler on, and probability of W given sprinkler off times probability of sprinkler off. So we sum over these, and probability of W given S and R is 0.8 times probability of S given R, is just probability of S because S and R are independent. So probability of W given S complement R. So that is here 0.7 times probability of S complement R is 0.8. Again, S and R are independent. So probability of S complement is probability of S complement given R is probability of S complement. That is 0.8. So doing the calculations, you get this 0.72, right? So now we just put the values in the main formula over here, right? So in this, we put the values, we get 0.8 times 0.2 divided by the of W given R is 0.72. That is 0.16 by 0.72. That is 2 by 9. That is 0.22. So that is the answer. Okay.